It's like his eyes are always like perfect. Like they're, well, not perfect. No, not like his eyes. Like his like.
Yeah, you go like this side, turn over.
I know you mean.
Okay.
It's just diabetic.
So let's go back to where we left
That is not
off,
diabetic.
which was in the notes. Example 2. We're ready for B, is that right? So here's our function, and we're going to figure out let's in as x approaches 2, all right? So we're going to find the limit as x approaches 2 from the left, and the limit as x approaches 2 from the right. All right, so read the directions. Does this make sense to you? This is our goal, right here. Does that make sense? Okay. All right, well, what do you notice about your problem? You're actually gonna have a hole, and we're just looking at this, right? Where's that hole gonna be? 2 comma what? 2, because that's what I cancel, and then comma what? No, we don't get 0.
-6?
-6. So if you were graphing this, you would have a hole, literally, in the graph at 2, -6. Would you agree with me? Is that okay? So the question says, what is happening to our y values as we approach 2?
How do we find the -6 for the whole base?
This is x, put x in,
Uh-oh.
right? We always find y by plugging in our x.
Okay.
So 2, -6. Now, what is happening to y as x gets closer to 2? Well, as x gets closer to 2, no matter, I don't know how this picture looks, but as x gets closer to 2, what are our y values doing? Getting closer to -6. -6. Both sides. Because when you draw this picture, the curve is going to go through that point, kind of skip over it, but it's going to be on both sides of that point. So no matter which side you're coming at it from, the y values are going to be getting closer and closer to 6. -6. It's not an asymptote. What?
But isn't there one at?
Oh, there would be an asymptote at 3, but the question is this. The question doesn't have anything to do with 3. Could the question have to do with 3? Yes. And if it did, then I'm not going to take time to graph this whole thing. But if it did say this kind of thing, there's an asymptote at 3 on this picture. What happens as you approach your asymptote? You're either going to go up or you're going to go down. So this answer will be either negative infinity or positive infinity, because that's what happens at an asymptote. But what happens at a hole is you have a y value. You have a y value. So the closer you get to the hole, the closer the x value gets to the hole, the closer the y value is going to get to the y value of the hole. All right, and what about C? Remember, our sole job is to figure out what happens as we approach 2 from the left and 2 from the right. Remember, when we're talking about x values, we're moving left and right. So that little plus means Right. If I were talking about Y values, that little plus would mean from the top, because that's up and down. So this is X. So left, right. All right, let's look at our function. What's happening here? Okay, let's simplify. Is this gonna have a hole? I cancel. Is it gonna have a hole? No, why not? Because it's still there, right? It's still there. So I canceled out part of it, but I didn't get rid of it altogether. What is this picture? What's gonna be happening at 2 in this picture? We're gonna have a vertical asymptote. We're gonna have a vertical asymptote at 2. We're also gonna have one at 1. Would you agree with that? We're gonna have 2 asymptotes in this. So I don't know what these are yet, but I know they're going to be either positive infinity or negative infinity. Because if you are coming at a vertical asymptote, I'm the asymptote, as you come at me, you can't hit me. You have to go either up or down, always. So how do I figure out, I need to know, let's do this side first. What's happening over here on the right side of the asymptote? Let's plug in a couple points. Let's put in 3. If I put in 3, I get -1 over 1 times 2. Do I get -1/2? Keep an eye on my arithmetic, is that right? I put in 3? Okay, now what happens if I put in 4? 0. So what does it look like is happening as I head toward the asymptote from the right side? It looks like it's going down. So from the right, that would be negative infinity. Now, I have a gut feeling what's happening on the other side, but I really don't know. So, let's pick a point here. Well, I guess I'd have to do like 1.5. So 1.5 would give me -2.5 over -1/2 times 1/2.
That'd just be 10.
It's going to be positive, right? And I really don't care about any other point, because if that's positive, it has to be going up, because what would happen if it went down from there? It would cross the x-axis. How many places does it cross the x-axis? 1. There's only one place it can equal 0. So I only need 1 point up there to know that that one's gonna be positive. So in between here, there must be some kind of a parabola type shape. All right, you okay with that, everybody? All right, now we're gonna do example 3. This is tricky. Now you are gonna write the equation of a function that has all of these characteristics. So with your partner, take a second and do that. See if you can come up with, actually, we're gonna second. Take a few minutes and see if you can come up with a function that does what it says.
I just put it in your left. Like not in a particular pocket.
And go ahead and put your ideas up here, and we'll check them out. I haven't done this either, so I'm gonna take a minute. Talk to each other, stay focused.
Attaboy,
Put your answer up there if you get a thought.
I don't even know how
It's funny, but it's bad. Nah, he said he was like, he said he was
Minus 3.
Okay, so gotta have this. You know what I'm saying? There's an asymptote from the left, it goes down. So you know that. Like I said, by moving down to negative as it approaches negative 5x, or not negative 1 from the left. What is that? So it has to be. Oh yeah, okay. And then it goes. I don't understand this at all. Oh, the whole set. I think I need I think that's it. Oh wait, all 4 of these are for that?
I'm looking at how would it be? Example 2. Not looking at
from the right.
So it's excellent.
It's like the shape of it should be
How do you keep
That's what it's saying. I'll be like, I gotta get Did you have the body picker?
It's gotta be this.
Oh yeah, I do. Something like that, right? She's like, oh, you want to go to I was so I did. Why does it make it like you start doing this. No, I mean it's like
Anybody got either one of them yet? I have A. Look, it's got it here, let's talk about it. Remember, there's more than one, I'm sure there's more than one possible answer. We're just gonna check to see if Alice says fits
We're almost there.
what it says. You're almost there? Good, keep going.
We got that part right. What? Seven? Where did you get just
Just chill out a minute.
No, I
So
saw
what we, yeah, go ahead and tell us what your logic was. Let's listen to his logic here, and then we're gonna make sure it does what it's supposed to.
So, the reason I did x minus 3 on the top and bottom is because there's a hole there, so you have to
Okay, so let's stop there. Does everybody understand what he said so far? He knows he needs an x minus 1 in the denominator because he has a vertical asymptote there. How does he know he has a vertical asymptote there? Because as we approach 1, we're shooting up and down. That happens at a vertical asymptote. That's the only time it happens, okay? And then he said, since I've got this x approaching 3 from the left and 3 from the right, but it's equaling a number, not infinity, a number, I must have a hole there. So he's got that built, okay.
And then I essentially just plug it in. So this part's essentially moved since it cancels out. And then so I plug 3 in for x to equal y equals 5. So then I get 3 plus n over 2 equals 5. So 10 equals 3 plus n. So 7 equals n.
Wait,
Okay, so again, he had this much built. He knew he had this in his problem. This just from the limit notation, he had that. Now, since these cancel, he would be left with just that, he would be left with this, right? Now, if it cancels, that means it's a hole, and according to the problem, if he plugs in 3, which is the thing that canceled, he's supposed to get what?
0?
No, what does it say in the problem? As x gets closer to 3,
Oh, 5.
y gets closer to 5. So his hole is the point 3 comma 5. If he stopped here, his hole would be at the point 3 comma 1/2. Okay, that's not what I want. I need it to be 5. So he said, well, when I plug in 3, I get 2 in my denominator, right? That would mean my numerator would have to equal 10. So 10 over 2, I would get my 5. So he said, what would make my numerator 10 if x is 3? And he said, well, one option would be x plus 7. Is that true?
Yep.
X plus 7? So his picture for this function right here, his picture would have a hole at 3 comma 5, a vertical asymptote at x equals 1. Now the only thing we have left to check is, I need to check to make sure that what's happening here, where's the problem? On either side, let's see, on the right side, I gotta be going up, and on the left side, I gotta be going down. That's what the problem says. So let's see if his is. Let's plug 2 into his problem. Now remember, when he put in 3, he got 5. If he's right, I need to plug in 2 and get a number bigger than 5. So let's see, if I put in 2, I get negative 1 times 9 over, oh, I don't need to put it in there. Well, doesn't matter. And then, what is that? Negative, if I put in 2, I get 1. Is that bigger than 5? Yep, perfect. Then I can check over here. If I put in 0, I get negative 7. If I put in negative 1, I would get 6 over negative 2. Wait a second. If I put in 0, I get negative 7. What do I get if I put in negative 1? Do I get negative 3? Oh yeah, that's right, because I want to be going down. Yep, I'm good. I'm good. So Alex, that's a great, great, great idea. Did anybody have a different idea?
Question though. If it was going the wrong way, could you just put a negative
Yep,
back in
that's
front?
exactly what you would do.
Okay.
So his question was, all right, so we have to check to make sure we're going up and down on the right sides. If we're not, then all you have to do is stick a negative 1 out here in front and that will tip it upside down. Now, it might also change that hole though, so you wanna be careful about that. All right, anybody have a different thought over here? All right, take a minute now that we've done that one, and let's see if you have a thought for the second one. Using the same kind of logic he used, can you come up with a thought for the second one?
I forgot to ask for, but then I realized it's not.
And then it's equal 4.
Remember, there's more than one answer. I'm gonna share my answers with you in a second. They're different. I have a different one than Alex. We'll see if Fred and I have.
That.
It doesn't matter if we do or not.
And I wanted that. I need that.
Oh, I was about to go up.
Dude, I was gonna go
I actually got it. I was so proud.
Well, let's see. We'll take, if yours doesn't match his, we'll compare.
Mine doesn't match, I can
I don't think
anything.
that works actually.
Cole, go put yours up.
Because originally we had x plus 2 over x plus 2 over x minus 2.
Is this yours?
And then we realized that.
Is this yours?
It's sort of.
Yeah, let me see.
Hey, I got -1. Because look, well, I'll explain why. With the asymptote, instead of from the left, it usually is supposed to go down. But if it's coming from the left, it goes up. So you got switching.
Where'd you do that X plus 6?
Oh, I did the big alpha.
We need, he made a change and he figured out it wasn't gonna work out the way he wanted. So, what do you have?
I think I think
I don't remember. I don't know. I feel like this is right. But she said there could be multiple. Do we have to have the negative out front? Like on this problem? On this problem specifically, like is the negative necessary?
I
Yeah,
don't know.
you got no. Like I know why you have to have it.
Okay, let's talk about that. We'll try to figure it out. All right, so,
Yeah.
so,
Big alpha.
explain here what's happening, Cole. What's
Explain.
happening? Yeah.
So the x plus 2 and the x plus 2. Oh wait, hold up. I wrote it wrong.
I don't either. That was baffling me. Okay. All right. So, before we get too deep in the weeds here, does everybody understand why he has this factor in his problem? There has to be an asymptote at -1, because what is the limit behavior? Positive and negative infinity. And that only happens when you have a vertical asymptote and you're shooting up and down. So that's gotta be there. Does he have a limit as x approaches -2? Yep. But that one is not an infinity, so those are gonna cancel and he's gonna have a hole. And where does the hole have to be? Well, it has to be at -2, 4. So he came up with this so that when he plugged in -2, he got 4 over -1, and he changed the sign, and he's gonna get 4. Would everybody agree with that? So this setup gives him the right hole. Now, what do we have to check to make sure? Does that setup, here's his asymptote, oh no, here's his asymptote, -1. Does that setup give him, let's see, I wanna go up on the left, and down on the right, according to, the limits, right?
It says plus on both sides.
Oh, wait,
Oh,
stop,
shoot.
it's plus on both sides. Oh, that caught me off guard too. Plus on both sides, that's gotta happen. I don't think this is gonna do that.
Doesn't that mean that you have to add another vertical asymptote?
Well,
Couldn't you just absolute
certainly
value?
we could add, we do anything we want. If we added another vertical asymptote somewhere, a lot of times that will be that behavior, but not necessarily on this side also. It'll be up in between there, or down in between them. I don't know, so did you add one and did it work? What did you put? So Cole, did you see your mistake? I made it too.
Yeah, I thought it like just switched. I didn't think they were both.
Yeah, I didn't pay any attention, so there we go, we're both screwed up. So we gotta make it going up on both sides. All right, anybody come up with a plan there? What do you have is right? What did we have? We have x minus, or x. It's negative 1. Yeah, oh, you got it. You got it. Okay, go ahead. I'll step aside.
Amy might get it.
I was doing some working on keys.
That's a make.
Is that a 12?
Is that
an
a
R?
12 or 2?
Where are we at? Right here?
It's pi.
Yeah, that all real numbers or not?
I'm not even sure. Oh, it's a +2. X plus 2, x plus 1, x minus 2, x plus 2.
Okay, so what did we have to have happen? We had to have a whole at negative 2, which we're going to. We had to have a vertical asymptote at negative 1, which we're going to. Would everybody agree with that? And I know that when I plug in negative 2, I have to get 4. So this one canceled.
It looks, yeah, it just looks a little long.
So when I plug in negative 2, I get 4. Correct. Now, because we spent a lot of time on this, I'm gonna type your equation into my calculator, and I'm gonna see if it has this behavior. I could do it by testing points, but we're running short of time, so I'm just gonna go ahead and type it in my calculator.
Is there any way that it can be up without having another vertical asymptote?
It's not.
No.
I don't understand it.
Oh yeah, you do. You can figure that out. What do you think?
Oh, I was just asking if we get a calculator for this section.
No. No, but we've already checked a ton of points, so we're, try this. What does that do?
Creates
Now, that might screw up my whole, my y value of my whole, but let's graph that on our calculator
just that.
and see how it behaves. Yeah, just graph this on your calculator. We'll adjust for the whole, that's the easy part. But let's see if that gives us end behavior the same on both sides of the asymptote. Okay, it does, but they're going the wrong way. So I've got 2 issues here. One issue is, this is how I'm gonna get same behavior on both sides of my asymptote. I'm gonna screw it. Okay? Now, I need that behavior to be going up instead of down. So go ahead and put a -1 on that and see if that makes you going up on both sides.
It's in there, bro.
Well, you gotta take it out from the bottom.
Okay, did that give me the right behavior now? So now I have to make an adjustment so that when I plug in, what's my whole? If I plug in -2, I have to get 4. So what do I get right now? If I plug in -2 right now, what do I get? If I plug in -2, I get -1 times -4 over -2.
What?
Do I get 4? So it's all good. Now, what if it weren't good? Well, then I would probably, instead of making this a -1, I would make it a -2 or a -1/5 or whatever it would take to make that Y value work out right. You see what I'm saying? I would make the adjustment, not Alex with another parentheses, but with a coefficient that would multiply it to make that number work right.
So it wouldn't matter if it was like whoever is number you
Why call Mr. Benson, bro?
Well, like
Well,
for
I
this
need
one,
it to be +4.
yeah.
I need
So
it to be
whatever.
positive.
Okay.
So if
No,
I
but
got
I-
lucky and it
last
just
time I
worked
did
out
it,
to
you
be
wrote from
positive
Cole.
4, but if it didn't, let's say when I put it in, it worked out to be 8. Then I would put a 2 down here in my denominator because that would divide that 8 by 2 and give me a 4. So again, I would make an adjustment with the coefficient, not with a new parentheses. I think it's easier to do that.
So is that the final equation? Or is it that equals to the bottom?
No, yeah, you still need those on the top. I was not plugging things in, but yes, so that would be where that comes out. This would be your
I always build those in
final
Minecraft.
equation.
It was just spell out.
No, you would-
Which one? Which Emery?
It's a tricky one.
Naughty or nice?
These are hard. There's one in your homework, actually 2 in your homework. If we get a chance, we'll look at them, but we gotta finish this first. All right, number 4. If you're not writing an equation, here you are sketching a picture. All right, so we're gonna sketch a picture that has this behavior. As x approaches 4 from the left, it increases without bound. So would you agree it looks something like that as it approaches 4 from the left? As it approaches from the right, it decreases without bound, okay? And it has a hole at 1. And maybe it's got a horizontal asymptote here, it doesn't tell me, but I have to draw the whole picture. So what do you think, does that picture satisfy the qualifications?
Meets my
Perfect.
standards.
Yeah, these were easier. It's easier to draw the picture than write the equation for sure. Okay, what about the second one?
You look like you're struggling.
As we approach -1 from the left, I decrease without bound. Okay. As I approach from the right, I decrease without bound. There are holes at -2 and at 3. Maybe put a horizontal asymptote in here. Would that picture satisfy the conditions of the problem?
Wait, so we can just place horizontal
Yeah,
asymptotes?
you're drawing a picture, drawing a sketch that has the following properties. It doesn't say anything about the horizontal asymptote, so I'm gonna put one in there.
How do you know like the line is like that and not like?
It could be, so it could have some kind of a slant asymptote. Yeah, I don't know, I have no idea. So it could be, that would be fine. This is, right here, this is the metric chart that has to be there. They have to be going down, down, and we have to have holes there. Other than that, it's free for all. Okay, all right, let's take a look at the next page, the whole tree. And let's go to the back side of it that says check your understanding. All right, we need to get this done, so here we go. Find the following. We're doing check your understanding on the back of the page called the whole tree. All right, so how are you gonna start this problem? Factor it, you're gonna factor everything. All right, so the top factors as x minus x plus, and the bottom factors as x plus 4 minus 1, double check that.
Good.
And we're finding all this stuff, okay? So right away, I see I'm going to have a hole. Would you agree with that? Let's do that first. Where's that hole gonna be? At -4, comma, what?
8.
Positive 8 fifths?
Oh, yeah.
Positive?
Wait, how do you?
You just plug X.
I'm just gonna go ahead and sketch it as I go. So -4,
Okay.
8 fifths is my hole. All right, what else can you tell me? Take a look at that right there. Do I have a vertical asymptote? I do, at x equals 1. What are vertical asymptotes? Cannot be's. X can be anything you want except 1. Can't be 1. All right, how about horizontal? I have an end behavior asymptote. What is it? One. Why is it 1? Y equals 1. Why is it y equals 1? X over x. Or in the original problem, x squared over x squared. Right? I need my zeros and my intercept. So here we go. Zeros and y-intercept. Zeros are x-intercepts. So zeros are going to be something common 0. The only way that fraction can be 0, anyway, any fraction can be 0. The only way a fraction can be 0 is if its numerator is 0. What makes that numerator 0? 4. So your only x-intercept, the only place you're going to cross the x-axis is right there. Because that is the only number that you could plug in and get 0. Now what about a y-intercept?
You just plug X.
I'm going to plug 0 in for x, and that's also 4? That doesn't always happen, that's just a random thing. So we've done number 1. Would you agree with that? Is that everybody okay with all those things?
Wait, whoa. Horizontal asymptotes, how'd you find it?
How do we find a horizontal asymptote?
It's like the x, dude. X squared over x squared.
Oh, so they
It's your
divide.
end behavior, you look at the power, the biggest terms, and compare them. When they match, it's 1 over 1.
Did you get the y or something yet? Plug in 0.
Plug in 0. Sweetheart, what do I know about any point on this line right here? Tell me, yeah. All right, now, without doing anything else, do I have enough here to sketch this, do you think? Yeah, I think it pretty much is gonna look like this. And then over here, it's gonna look like this. Does that make sense to everybody?
Was there like, did we have to get like the 4 0 or could we get like a different one? Like, did we need, like, is that the only one we could find or something? Is that like a dumb question?
I I don't understand the question. You can find as many points as you want. There are infinitely many points up there, but the question specifically said, what is your x-intercept?
Oh, okay.
Zeros are x-intercepts. So, yeah, there's billions of points you could find, but you were asked for that particular one, and there's only one x-intercept. In this problem, there could be more. All right, so what does question number 2 say? Evaluate f of x at an expect value to the left and right of the vertical asymptote to determine if it's going up or down. Well, we already did that with our intercepts and our holes and all that, so we didn't even really need to do problem 2. You know, on the left of the asymptote, we're going up, and on the right of the asymptote, we're going down. Right? We can just tell that from the information we already had. We didn't need to plot any more points. All right. Now we're going to do one more problem. 1, 2, 3, or 4. Let me pick a good one. Let's do 2. Let's do 2. Problem number 2. So on the next page, it's called Rational Function Practice. We're going to do problem number 2. Notice that the last question is to draw the graph. So I'm going to jump to the last question because to draw my graph, what do I need to find? I need to find any asymptotes and intercepts, right? So will problem number 2 have any holes? Not going to have any holes. Does it have any asymptotes? Yes. Where? It has x equals 0 is a vertical asymptote, which means I'm not going to have a y-intercept. Agreed? No y-intercept. Got an asymptote there. Cannot be. Does it have a horizontal asymptote? Where is it? -1. Y equals -1. Why is my horizontal asymptote at -1? Negative x over x, yeah. Now, I already said I don't have any y-intercept because I can't let x be 0. But is there any way the numerator will be 0? Yeah? How could the numerator be 0? If x is what? 1. So that point right there is my x-intercept. Remember, what's an x-intercept? It's where y equals 0. So if you put 1 in here, y is going to equal 0. So that's it of like the important stuff. Can you tell what this looks like over here? Isn't it going to look like this? Now, what about over here? Don't forget about this side of the picture. What's this going to look like? Any idea?
Plug it in.
We could plug in points. Anytime you're graphing anything in your whole life, anywhere, you can always plot points. But I don't think you need to in this problem. It will always work. You can always do it. But I don't think you need to. Mary Kate, what's your thought?
It's just gonna go like that.
It's going to go like this. Now, some of you might say, well, of course it is, because they're kind of opposite each other. But no, there's a mathematical reason it has to be down here. If it were up on top, it would have to look like this, because it has to approach its asymptotes. Why can't it look like that top one? It can't cross the x-axis. There's only one place it can cross, kids, right there. We figured that out. So it ain't gonna cross ever again. So it can't look like the top one, so it has to look like the bottom one. Now let's answer the rest of the questions. We got it drawn. We've done number 3, we got our x-intercept, there's no y-intercept. Evaluate the limit x approaches infinity, and as x approaches negative infinity. What's the limit? Y equals -1. And we did the asymptotes and holes. So are we okay with that? All right, there's more in there for you to practice on your own if you wish, that's fine. I am gonna go ahead and assign the 1819, or no, what is it, 19110, homework. It's all one. It's 2 lessons together, so do the 910 assignment, that'll be due on Friday.